All right, here is our lesson 2 homework key. We are using derivative rules to easily find the tangent slope generating function for an original function. That's what we call the derivative, the tangent slope. Here, the derivative function, tangent slope generator. Power rule. Bring the power down, subtract 1 from the power. Bring the power down, subtract 1 from the power. Bring the power down, subtract 1 from the power. You can think of it as x to the first. Bring 1 down, subtract 1, you get x to the 0. This is just 1. Derivative of 1 is just 0. So the derivative of 1 is 0. Now these guys, we're going to have to rewrite them as x to the negative first, x to the negative second, and x to the negative third. Taking the derivative using the power rule, I'd get negative 1x to the negative second. I would get negative 2x to the negative third. I'd get negative 3x to the negative fourth. We can rewrite these if we want to as negative 1 over x squared, negative 2 over x cubed, negative 3 over x to the fourth. Okay. Let me erase these arrows. So it looks nicer. And just so we know what I did, that process was take the derivative. Let's take the derivative here. Now we need to be comfortable with saying that the derivative of y is y prime, or dy dx, that whole multiplication process. This represents tangent slope. Here we go. Bring the 3 down, subtract 1. Bring the 2 down, multiply by the 3, subtract 1. Derivative of 2x is just 2. The derivative of 5 is 0. This is x to the 1/3. Bring the 1/3 down. Subtract 1 from 1/3, negative 2/3. Remember, you're subtracting 1. That's like subtracting 3/3. I would rewrite minus 2 over x is minus 2x to the negative first. Multiplying that negative 1 by the 2 would be like minus a negative. That would make that a positive 2, x to the negative second. Bringing the minus 3, I like to, whenever I see subtractions, so make it add the opposite, add the opposite. So this is negative 3x to the negative second. Use the power rule in numerators. Negative 2 times negative 3, positive 6x to the negative third. And you could rewrite this as 2 over x squared and 6 over x cubed. The tangent slope generator for cosine is negative sine. The tangent slope generator for sine is positive cosine. So let's be careful here. Okay, 3 cosine. It's just a constant times cosine. It's not 0 times sine. No. Remember, the constant multiple rule says if you have a constant in front of a function, just like we did up here at 4x cubed, I don't take the derivative of 4 and say it's 0. I just take the 3 and multiply by the 4. So the 4 kind of just stays. So the derivative of a constant times a function is just the constant times the derivative of the function. So don't take the derivative of the 3. Instead, just leave the 3. But the derivative of cosine is negative sine, so that negative can come in front of the 3. The derivative of negative sine will be negative cosine. The 5th root of x squared. Rewrite this as x to the, what is it, 5/2, 2/5? Let's think. That's x squared to the 1/5. That's x to the 2/5. Okay. Bring the 2/5 down. Subtract 1. That would be subtracting 5/5. That's negative 3/5. This can be rewritten as 2 over 5 x to the positive 3/5, which could be written as 2 over, different ways to rewrite this, but you can have the 5th root of x cubed or x cubed 5th rooted. I think we're mostly used to saying x cubed 5th rooted. Okay. Let's see this guy. Derivative of h, I'll say is h prime. 3 sine, 3 positive cosine. Positive cosine, negative sine. X squared, 2x. Okay, great. Okay, find the slope of the tangent to the previous functions at these points. All right, well, this is easy because we have tangent slope generators. This is a tangent slope generator for f. This is a tangent slope generator for y. This is a tangent slope generator for g. It's a tangent slope generator for h. So let's start with f prime at 1. All right, so I will have, do it here, 4 plus 3 plus 2 plus 1 minus 1 minus 2 minus 3. So 1s, 2s, 3s, I just get 4. That's nice. I'm just going to leave these instead of the crossing off. 4 plus 3 plus 2 plus 1 minus 1 minus 2 minus 3. Okay, y prime at 1. I'll write it as y prime at 1. Or dy dx at x equals 1. We'll put it like underneath the dy dx for notation of you're taking the derivative at 1 or you're finding the slope of the tangent at 1. 12 plus 6 plus 2 plus a third plus 2 plus 6. So 18, 20, 28 plus a third. So I can just leave it as 28 and a third. Probably want to turn that into a fraction. 28 times 3, 4, 2, 6, 7, 8, 84 thirds plus a third is 85 thirds. Just double check that. Yep. All right. G prime at pi. So I got negative 3 sine of pi. Sine of pi is 0. Cosine of pi is negative 1, so it's minus negative 1 or plus 1. And then plus 2 over 5 pi to the 3/5. Do I know what pi to the 3/5 is? No. Am I expected to know it? No. What am I going to do then? Don't worry. Sometimes you're going to have crazy looking answers, but they're still correct. 1 plus 2 over 5 pi to the 3/5 is perfect. All right, now h prime at pi over 4. I got 3 cosine pi over 4. Cosine of pi over 4 is root 2 over 2. Sine of pi over 4, root 2 over 2, but it would be negative root 2 over 2. Then minus 2 pi over 4. One thing we'd have to do is combine these root 2 over 2's. Now I have 3 root 2 over 2's, and I have negative 1 root 2 over 2. That is 2 root 2 over 2's. And then the 2 root 2's over 2, the 2's will cancel. So I actually just get that h prime of pi over 4 is root 2 minus, this cancels to be pi over 2. That, okay, sweet. Moving on. Find the equation line to the equation of the tangent line to this. Remember, for tangent lines, I need a point and a slope. Think about the visual. You got some sort of x squared graph. It looks something like that. We have a tangent equation at 1. Maybe it's positive, maybe it's negative, I don't know. The point comes from the function. The slope comes from the tangent slope at 1. Okay? Point comes from y, slope comes from y prime. So point, y at 1. 1 plus 2 minus 3, 0. Nice. So this is located at 0. Y prime, 2x plus 2, y prime at 1, or dy dx at x equals 1 is 4. Okay, y minus, my point is 1, 0, equals m, tangent slope, x minus x1. Piece of cake. Cosine, pi over 3, point, slope. Point comes from the function. It's where our tangent line will pass through. Cosine of pi over 3. Oh man. Trigonometry. It doesn't disappear on us. It just stays around. This is a half. Remember pi over 3, taller, 30, 60, 90 triangle. Cosine horizontal to be the shorter side. Slope comes from the tangent slope generator. Beautiful, beautiful function where we can just plug in x's and we get tangent slopes, instantaneous rates of change. Incredible. Tangent slope generator for cosine is negative sine. At pi over 3, I get negative sine pi over 3. Sine of pi over 3 is root 3 over 2, so this would be negative root 3 over 2. My point, pi over 3, 1/2. My slope, negative root 3 over 2. Here's my equation. Y minus y1 equals m times x minus x1. What's great about this is you can always check to see if you are correct if you have a graphing calculator. So watch what I'm going to do. Pop up my graphing calculator. Graph cosine of x. If I've done my correct job, if I graph negative root 3 over 2 times x minus pi over 3, and then I add a half, I should see a tangent line to cosine at pi over 3. Yes. Let's see. Plug in pi over 3. Boom. I can zoom in right there just to make sure. Tangent. Awesome. You've done that with this one as well. All right, here we go. Negative 3x cubed plus 2 over x squared. We'll do both processes. We'll check as well. Point y at negative 2 equals negative 8 times negative 3. That's positive 24 plus 2 times, this will be 4. This will be 1/2. This is 48 halves. So this is 49 halves. Okay? Slope. Y prime. dy dx. Negative 9x squared. This turns into 2x to the negative second. So that's negative 4x to the negative third. I'll rewrite it as negative 4 over x cubed. But I'll just remember that. So when I try to find y prime at negative 2, same as dy dx at negative 2, I get positive 4 times 9, negative 36. And then I get negative 4 over, so this turns into negative 4 over x cubed. So this is negative 4 over negative 8, which is positive 1/2. Negative 2 cubed, negative 8, negative 4, negative 8. Boom. Okay. 36 is 72 halves. So plus a half would be negative 71 halves. So that's my slope. And my point I have is negative 2, 49 halves. And my equation is y minus 49 halves equals my slope, x plus 2. Plus 2 because it's minus a negative 2. Let's see. I don't think I'll be able to see it on the Zoom standard. Oh, I almost do. So let's see, the point's at 49 halves. That's like 24, so let's just adjust my window. This is a cool looking graph here. Let's go up to like 25. And I can see at the point x equals -2. Oh, I think it's correct, but I actually think I'm off by a little bit. Is it not 49 halves? -2 cubed is -8 times 3, positive 24. And then -2 squared is 4, so that's 2/4. That's 1/2. What's 49 halves? Not 23.75. Did I type the function in wrong? Yes, I did. Okay, phew. Squared graph. Whoa. Okay, cool. Now I should see what I should be seeing. Yep. All right, 24.5. There's boom. There's the function. There's the tangent. Great. All right. Find the locations where the tangent slope equals 4. All right. Well, here's my tangent slope generator. When does this equal 4? Gosh, this is when we're going to use our friendly equation. Okay? When does the tangent slope generator generate a tangent slope of 4? We have the power of equations to find when things will produce certain values. We get x equals plus or minus the square root of 4/3. So I am telling you that at positive root 4/3 and at negative root 4/3, you will have a tangent slope at x cubed that equals 4. How can we confirm that? Different ways. You can visually kind of see it. You could graph the slopes of the tangents. You can graph the tangent lines, and it'll all work out. Find the equation of the line tangent to this and parallel to this. Well, first of all, I need to find out the slope here. And let's think about this visually. I got some sort of parabola, and I have this y equals, this is 4x plus 3. Now, 4x plus 3 is not going to be tangent to this. This is the graph of 4x plus 3. It looks like that. But what I want to do is find the line that is tangent to this parabola that is parallel to this line. Now, what do these lines share? The slopes are the same. So this tangent slope must equal the slope of this red line. This is very, very important, kind of thinking about this. So visualizing this. So I need to figure out when our tangent slope, which tangent slope generator is 2x minus 6, generates a slope of 4. We could solve, add 4, divide by 2, when x is 5. Now, that's great. That's the location. When x is 5, this will have a tangent slope of 4. We are asked to find the equation of that. This will be a beautiful thing to graph and check. So we know that when x is 5, and here comes my equation. When x is 5, my slope is 4. Double checking, 10 minus 6, 4, yes. Okay, but my point now is my function at 5. So I need to go back and find the point where I have a tangent slope that's 4. 25 minus 30 plus 2. So that's -5 plus 2 is -3. Okay, so I say that the point 5, -3 will have a slope of 4. My equation will be y plus 3, it's y minus y1 equals m times x minus x1. Let's check and see the beautiful, beautiful graph of x squared minus 6x plus 2, the line 4x plus 3, which won't be tangent, but the line 4x minus 5 minus 3, which will be tangent. Oh, I feel like they're not like the same slope. I think the window being all messed up, yeah, that looks better. So that's great. Here's that line in red, which is the 4x plus 3 line. This is tangent to the parabola, and it's parallel to that line. Isn't that great? Yeah, I know you're happy with it. All right, find the equation of the line or lines tangent to x cubed plus 4x plus 1 and parallel to this line. Well, this line has a slope of 16. Let's think about this visually. We kind of know what an x cubed looks like. I don't know exactly what this x cubed looks like, but you know, x cubed. Well, it looks like I'm probably going to have two situations where I'll have tangent lines that are going to be parallel to, this is like here. So keeping that in mind, we might be looking for two different solutions here. So let's go ahead and do some work here. So when will my tangent slopes generate a slope of 16? Find the tangent slope generator. Set it equal to 16. Subtract 4. Divide by 3. Okay. X will equal plus or minus 2. Now, we are saying we now have two locations, which means two equations. When x equals -2 and when x equals 2. I know what my slope is going to be. The slope at -2 is 16. The slope at 2 is 16. I already solved it. You can double check it. I have to find my point. Y at -2. So I get -8 minus 8 plus 1, -15. And then at 2, I get 8 plus 8 plus 1, 17. Giving me my equations, y plus 15 equals 16, x plus 2, and y minus 17 equals 16, x minus 2. Okay, let's see. I got x cubed plus 4x plus 1. I got the line that is not tangent, 16, x minus 3 plus 2. I got my tangent line. So my tangent lines will be in black and pink. 16. X plus 2 minus 15 when I solve this equation for y, and 16 x minus 2 plus 17. Here we go. Oh, wow. So cubic, it doesn't curl over like I thought it would. They don't always do. Red line is this line. Parallel to the red line is the black and the pink line. The black line and the pink line will be tangent to that cubic. Phenomenal. All right. To a tough question. Find k such that y equals -2x plus 3 is tangent to this function. So it's like we have this line -2x plus 3. Here's that's not -2x plus 3. Here is -2x plus 3. I want to manipulate this parabola so that this parabola somehow fits and is tangent to this. Now again, the visualization is important. It's better to kind of understand visually what things are going to look at so that you can understand what's going to help you to find this k. Well, for this to occur, two things need to happen. First, the slope of this line has to equal the slope of the tangent to this function at the point. Okay, so that's one thing. The second thing is that they must share the point. So for a certain x value, the y's will equal each other. So that's going to create two equations for me. A shared point, where negative 2x plus 3 will equal kx squared minus 2 at some location, and a shared slope. Where the slope of the line, or the derivative of this, will equal the slope of this. Okay, the derivative of 2 is just 0. Okay, what do I do? Well, I got two equations and two unknowns. Use my friend's substitution. Now, what should I substitute? It's actually going to be easy if I solve one of these equations, this equation, for one of these variables. I'm probably going to solve for k, so that when I substitute in for k, the x's will go away, and I don't have to substitute in two different locations. So I'm going to divide by 2x on both sides to get negative 1 over x is equal to k. I will take that, and I will plug it in to k. Let me just kind of show that carefully. So I get 2x plus 3 equals negative 1 over x, x squared minus 2. This simplifies to be negative x. The x squared divided by the x cancels one of the x's. This is an equation I can solve. So, I don't know, add 2x, add 2, I get 5 is equal to x. Okay, that's what x is. What's k? K equals negative 1/5. I don't know if I should feel good about myself until I use my graphing calculator to visually see what I'm looking for, which is that the equation negative 1/5 x squared minus 2 will have a tangent line negative 2x plus 3. Yes! You should feel good about yourselves. So it turns out, like, nope, can't happen opening upwards. It had to open downwards like that. Oh, isn't that great? That's just great. I'm going to redraw this picture just so for the key we are comfortable and we see it. Oh, that's not good. I can do better. There we go. Okay. The two equations share a point and a slope. That's a tough problem if you don't know where to start. So I assume that a lot of people came to the video for that. All right, the function bx squared minus 2x is a tangent line at x equals 3 that is parallel to the line connecting the points 3, 8, and 1, negative 4. Find b to make this true. All right, well, this function has a tangent line at 3 that is parallel to this line. So let's just write that down. The function f prime at 3 will equal the slope connecting the 2 points. Let's find said slope. y2 minus y1, x2 minus x1, 6. Okay. This slope generator for f, now b is just a number, so I would take the 2, bring it down, it'd be 2bx minus 2, the tangent slope generator for 2x. That tangent slope generator is what we have for f. Well, this tangent slope generator at 3, which will give us 2 times b times 3 minus 2, has to equal 6. 6b minus 2 equals 6. 6b equals 8. B equals 8/6, which is 4/3. Okay, fantastic. Graph that. Last two. Find a and b such that f of x is differentiable everywhere. We weren't able to get to this in class, but it is on the video. These are tricky. Now, being differentiable, we did talk about being differentiable. Differentiable means you are continuous, because you can't have a tangent slope where there's a discontinuity. And differentiable also means that you don't have a sharp point. We have these piecewise functions. Not only do we need to ensure that they meet up, this ax plus 5 and this 3x squared plus b, not only do we need to make sure that they meet up so that they're continuous, similar to what we did last unit, but they need to meet up in such a way that they are forming a very smooth connection so that there's no sharp point at this location, which means there are two things you need to check and make sure. One, that you are continuous at x equals 2, which means, remember what we did, f little 1 at 2 needs to meet up with f little 2 at 2. 2a plus 5 equals, this is 4 times 3 is 12 plus b. Great. But the second thing now we need to make sure is that we don't have any sharp points. To ensure we don't have any sharp points, the tangent slopes need to be approaching the same value. The tangent slope of my first little piece needs to equal and approach the same value of the tangent slope of my second little piece. Let me show you what that looks like. Now, a is just a number, so the derivative of ax is just a. At 2, still just a. But the second piece, the tangent slope generator for 3x squared plus b is 6x plus the derivative of b, b being a number, is just 0. But at 2, the tangent slope to the second piece at 2 is 12. That gives me what a is. Take that, plug it in. (29) equals 12 plus b. 17 is b. Got it? All right, well, let's see. Step 1, continuous. Here, this piece needs to meet up with this piece, which is just a flat line, at 1. I can't believe I didn't have any horizontal tangent questions here. We'll have to practice that. I say that because this line, y equals 3, has a slope of 0. So I'm going to have a horizontal tangent to this at 1, but I digress. So first little piece needs to meet up with the second little piece at 1. So a plus b has got to equal 3. Okay, I'm not plugging in 1 into anything, so it's just 3. Second guy, no sharp points. This won't have a sharp point, this won't, but it's all about the connection. The first piece, its derivative at 1 must equal the second piece's derivative at 1. Okay. The first piece's derivative, since a and b are numbers, are 2ax plus b. Now that's the derivative, but at 1, it's 2a plus b. The second piece is derivative. This is a horizontal line. The derivative of a number is just 0. So its tangent slopes are always 0. I got two equations, two unknowns. Let's use our friend substitution. B is equal to negative 2a. Solve this for b. Substitute it in. A plus negative 2a equals 3. So negative a equals 3. A equals negative 3. B will equal 6. I want to just check that. I can graph. I know there are ways to graph piecewise functions using your calculator. I don't even know what they are, but I will be able to see, hopefully, that at 1, they will connect, and at 1, it'll be a nice smooth connection. So I can kind of see if I almost watch. So I can see my x squared flattens out just in time to meet up with y equals 3 right at 1. I win. Okay. I hope you've all won. I hope we're all comfortable with any of these. I hope we're all ready to answer a question like find the x-coordinate locations where the slope of the tangent equals 0, or when we have a horizontal tangent. We'll make sure I do a practice one of those on your quiz before we take the quiz. I'm surprised I didn't put any horizontal tangent questions on this quiz, but I didn't, and it's okay. That's it. I hope we are doing well with this stuff. Thank you.